Today's lesson is about Venn diagrams. Jeremiah didn't take a nap today, so we may have a guest appearance in this video a time or two. So first of all, looking at the vocab. Our first vocab term is set, and that's just a collection of objects or numbers. Each object or number in the set is called an element. So for example, I gave you the set 2, 4, 6, 8, and each element, for example 2, would be a number in that set. Venn diagrams, hopefully you're familiar with these. They show the relationships between sets. You usually see them as a group of overlapping circles, and then you'll have elements that are in one set and not another. So for example, when we're looking at set A, here, beautiful circle. 1, 3, and 5 are in set A. They are not in set B. Looking at set B, 8 and 10 are in set B, they are not in set C. And then of course these overlapping circles right here, 2, 4, and 6, are in both sets. And our last vocab term for this lesson is complement, and those are values that are outside of a set, but they could be included in the universal set. So if you notice there's a box around the diagram, and it's called U for the universal set. We could have elements in U that don't show up in either circle. In our case, the two elements that are outside set A are simply 8 and 10. We didn't have any elements in U that are not in either A or B. So looking at our first example, we have set U, the universal set. So that's what's in the box outside of the circle. And we're also given what's in set A inside the circle. All right, so sketching our Venn diagram, I've already got it partially set up for you. We're just going to fill it in. So the elements 2, 7, and 8 are in A and also the universal set, so those are going inside our circle. And then outside the circle in the box that are in the universal set but not in set A would be 3 and 5. Say hi. So the complement of A, elements that are outside set A, would be 3 and 5. They're in the universal set, but they are not in set A. Next, we've got two sets. So first, what I do when I set up a Venn diagram for two sets is I figure out what elements are in both. I put those in the overlapping part, and then I put the unique elements in either set. So the first element in both sets is 5, and they also share 8. So the elements in A, other than 5 and 8, are 0, 3, and 14. And the elements in B that are not 5 and 8 are 1, 4, 11, and 13. And then we had no elements outside set A or set B. We weren't given anything in the universal set. So next we're going to determine how many elements are in each set below. So for example, part A, we're looking at the intersection. Remember, N means intersection, U means union, or both. So just what's in both together is 2 elements, just 5 and 8. The union, what's in all of them, we have 3 items in A, plus the 2 items in both, plus the 4 items in B, give us a total of 9 elements. And finally, A and B complement. So looking at B complement, what is outside of B is simply 0, 3, and 14. Those 3 elements are in B complement, and they are also in A. The 2 elements that A and B share would not be in B complement, so we wouldn't count those. All right, so next we're just going to simply shade each region on the Venn diagram. So the first one we're told to shade is A union B. So that would be everything in A and everything in B. So we shade in all of the circle, all of both circles. Next, A complement intersection B. So what's outside of A, but is also contained in B. So this piece right here is outside of A, but inside of B. So that's what we're asked for on this one. Say hi. You're so shy, but you keep popping up in the video. And finally, the last one is A intersection B complement. So A intersection B is this. So we're shading everything outside of that. So everything in the box, but that is outside the intersection. So it's all of A, all of B, except, and the universal set, except where they overlap. All right, now we're just going to do a couple of application problems with Venn diagrams, and then we're going to wrap this video up. So we're at a party. So 15 people ate cake, 10 people ate ice cream, 20 people had both, and then 5 people chose to have no dessert. So the question is, how many people ate cake or ice cream? So we can see quite easily on our Venn diagram, we have 15 plus 10 for a total of 25 people had one item or the other. And our last example, Drew took a survey of his classmates to see which sport they were involved in. So we're just going to practice reading this Venn diagram. So our first question, how many classmates play only one sport? So we're going to add up those numbers that are just in one circle. So we've got 9 plus 9 is a total of 18 people. How many play more than one sport? So that would be all of the people inside at least one, or at least 2 circles inside one of the overlapping sections. So we have 32, if I can add correctly and quickly. And then the final question is, how many play at most one sport? So that's going to be all of the people that play one sport plus the 8 people that don't play any at all. So 18 plus 8 gives us a total of 26. And here's your you try question. Last chance, do you want to say goodbye?